Hello and welcome to Mr. Tompkins EdTech and a brand new series of videos aimed at helping you prepare for your GCSE mathematics exams. In this series I'll be giving a complete walkthrough of the GCSE mathematics practice papers to help you prepare for your exams this summer. Now there are not so many of these and you don't want to squander them, so make sure you try the paper yourself first before you look at these solutions.
This particular paper is AQA November 2019, Paper 1, Foundation Tier.
Check the front cover of your paper to make sure it's the same one. If it's not, have a look through the playlist linked above, which includes all the GCSE Maths video walkthroughs I've recorded so far. I'm busy recording all of the GCSE practice papers, so if the one you're looking for isn't there already, why not subscribe by clicking the big red button below and check back in a few days. Don't forget to click on the bell so that you'll get a notification when I upload the next paper. I'll put timestamps in the description below, so you can choose to watch the whole thing through, or you can click on the timestamp and jump to the particular question you need help with. If you have a question, check the comments below, as someone else might have already asked the same thing. If it's a new question, leave it in the comments and I will try and answer all of them as soon as I can. Don't forget to mention which question on the paper you're referring to and try and be as specific as possible. Finally, if this video helps you with your revision, please give it a thumbs up. It will really help me out, and why not share the link with your friends, because they might need a helping hand too. Okay, let's get into it.
Question 1. Circle the value of the digit 9 in the number 7.962. So you can see the 9 here. Look, it's in the position directly to the right of the decimal point. This one is units, isn't it? Whole numbers. And then if you were going left of that, you get tens, hundreds, thousands. To the right of the decimal point, that first one is tenths. Tenths. And then you get hundredths. And thousandths, don't you? Okay, so the one we want is in the tenths column, and if I got 9 of them, then I've got 9 tenths, haven't I? Question 2, solve 3x equals 6, circle your answer. So if I got 3x equals 6, I want to get x by itself. To do that, I'm going to be dividing both sides by 3. This is going to cancel with this, leaving you with just the x, and on the other side 3 goes in 6 twice, so it's going to be x is equal to 2. It's that one there. Question 3, circle the correct statement, and I've got 4 different statements here, all involving 0.3 and a quarter, trying to work out which one is bigger. Now, in order to do that easy, probably the easiest thing to do is just to convert 1/4 into a decimal first. You know what 1/4 is? I kind of just remember it's 0.25. So if you think about a half is 0.5, you half it again, you're going to get a quarter. It's 0.25. So we're comparing these two decimals. When you're comparing decimals, just compare like left digit with left digit. They're the same. The units are the same. The tenths, one is a 3 and one is the 2. So the 3 is bigger than the 2. So you know, that's the bigger one, then, isn't it? It's going to be this way around. 0.3 is bigger than 0.2. Now that 5 on the end we don't look at all, because we just compare like digit with like digits from left to right. So yeah, it's going to be that one. Question 4, circle the number that is closest in value to the square root of 50. Okay, so now the square root of 50 is not a square number, is it? So I'm not going to be able to just write down the square root of 50. Normally I'd need a calculator, but this is the non-calculator paper, so what to do? Well, I know my squares. I've got 1, 4, 9, 16, 25, 36, 49, 64. Okay, so they're the squares up to 8. Now I do recommend you just memorize your squares up to at least up to 10. So they're super handy, especially for sort of questions like this. Now 50, you can see, kind of lies between 49 and 64, and actually it's very close to 49, isn't it? Not very close at all to 64. Now if you square root 49, you're going to get 7, aren't you? So if you square root this one, you're going to get 7. If you square root 64, you're going to get 8. So it's either going to be 7 or 8 closest, but you know, just if you think about the number line and how close 50 is to 49 compared to 64, I think we can be fairly confident that it's going to be that one there. It's going to be 7. Question 5, work out 76 times 24. Okay, so I've got a 2-digit number by times and by a 2-digit number. So if you know how to do column multiplication, just go ahead and use that one. If you're struggling with column multiplication, and I know many foundation students do, you know, maybe it's worth investing a little bit of time and effort learning another algorithm that you do get on more easily with. One I like to recommend to foundation students who do struggle with column multiplication is the Napier-Bones method. Now, the trickiest thing about Napier-Bones method is probably drawing the grid. You kind of make a bunch of squares the same size as your numbers. So this is a 2-digit number by a 2-digit number. So I've got 2 cells along here, so I can write my 76. And I've got 2 cells in this direction, 24. And notice that we divide them from diagonally from bottom to top, if you're looking at it from left to right. Now, if you can draw this grid reliably, then I think this is a really good method for multiplying. Now, once I've got the grid set up, I can start doing the multiplying. Now, in this box here, you can see it's in the 7 column and the 2 row. So I'm going to multiply those two things together. 7 times 2 is 14. So I'm going to write the 1 from the 14 in here and the 4 from the 14 in here. Okay, similarly, 6 times 2 is 12. So I'm going to write 1 from the 12 in there and 2 from the 12 in there. Now I'm on to the next row. Now, this box here, look, is in the 7 column and the 4 row. So I'm going to multiply those two things together to get that answer. 7 times 4 is 28. So the 2 from the 28 goes there. The 8 from the 28 goes there. And finally, I've got 6 times 4. 6 times 4 is 24. So 2 and 4 like that. Okay. Now, the clever thing about this method is you kind of add up along these diagonals that are created from the diagonal lines. Okay, and if you do that, then you don't have to worry about kind of adding zeros and carrying things and stuff like that. So it's a lot more straightforward. So that first diagonal adds up to 4. This next one, 8, 2, and 2, that adds up to 12. So I put the 2 from the 12 there, and I'm going to carry the 1 from the 12 into the next diagonal. The next diagonal then has got a 1, a 4, a 2, and a 1. So that adds up to 8. And finally, I've got 1 in the last diagonal. So my answer is then, you can just read the answer round, down, and around like this. So the answer then is equal to 1, 8, 2, 4, like that. Okay? So like I say, if you struggle with multiplying using the column multiplication method, then, you know, maybe this one is for you. I find it's a lot easier algorithm to learn, and there's a lot less opportunities for making mistakes with it. So anyway, maybe one for you to try. Question 6. The composite bar chart shows the number of students in some classes. So we've got a composite bar chart is where you've got like one type on top of the other. In this case, we've got the boys on the bottom and the girls on the top. So the bar kind of shows you the height of both groups, but you can read off also the values for the boys and girls individually by looking at the height of the parts of the graph. Okay, so how many boys are in the physics class? So boys physics then is going to be these guys down here then, isn't it? Okay, so if you read that off to the axes, you can probably see that that's like 3 squares up. So 5, and I've got 5 divisions between 5 and 10, so each one of those is going to be 1. So that's going to be a height of 8 then, isn't it? So there are 8 boys in the physics class. How many girls are there in the English class? So girls English is going to be these guys up here. Now the ones on the top is slightly harder to read because, well, it doesn't start from 0, does it? This bar actually starts from here. It starts from 13 and it goes up to here on my scale, which I think is 29. So then the amount of girls then is going to be the difference between those two numbers, isn't it? In other words, 29 take away 13. So 29 take away 13 is 19, 16, isn't it? 16. So they're going to be 16 girls. Which two classes have the same total number of students? So if they're going to have the same total number of students, the bars are going to be the same height. I think you can see it's that one there, isn't it? It's the physics and the French group. That's the same number of students at 23. Okay, so which two classes have the same total number of groups? Physics and French. Okay, and then finally, in the history class, there are 18 students and the number of boys equal the number of girls. So show this information on the chart. So we haven't got history yet, so I'm going to write history here on my bar chart. Okay, so I'm going to try and draw it the same style as the other. So I'm going to draw the height of the bar first. So there are 18 students. Where's 18? So 18 on my scale. There's 20s to come down to. It's going to be there then. Let me draw the height of the bar first. Right there. Okay, and then I can draw the sides. So that bar represents the 18 students, but I'm going to have to divide it up into a boys and girls section. So if there are 18 altogether and half are boys and half are girls, then half of 18 is 9, isn't it? So I'm going to have to divide this bar at 9, and then I'm going to have 9 above and 9 below then in that case, aren't I? So there we go, there's 9 at that point there. So if I'm going to shade this bottom bit so it's the same as the key, so I've got boys shaded and girls a bit lighter up. Okay, so that's my bar. I think I'm done. Question 7a, work out 1.86 divided by 6. Okay, I'm going to do this by short division, so I'm going to put the divisor out the front of the bus shelter, and then the number I want to divide in the bus shelter. Now, how many times does 6 go into 1? No times at all, does it? So that goes in no times, and I'm going to bring the remainder over, which is 1, to the next number along. Okay, now the decimal point comes between those two numbers, so it's going to be the same for my answer as well. It's going to be in the same place there. And I'm going to say, well, how many times does 6 go, not into 8, but into 18? 6 goes into 18 3 times, remainder 0. So just scooting on to the next digit, 6 into 6 goes once only. So my answer then is 0.31. Okay. The next part says 0.4 times 0.2. So you can just multiply the digits together. So 0.4 times 4 times 2 is 8. Okay, but because my question has got two decimal points showing, one in the first number, one in the second, I'm expecting there to be the same number in my answer. So I'm expecting there to be 2 digits after the decimal point, just like there are in the question. Okay, so I'm going to have to fill in an extra 0 there, so that makes it 0.08. Okay, so you need the same number of decimal points in your answer as you do in the original numbers. Okay, so that's why it's 0.08. Question 8, here are 4 number cards. I've got 8.6, 0.27, 6.3 and 0.4. Part A says choose 2 of the cards to make the answer to this calculation a whole number. Include the answers to the calculation. Okay, so which 2 can I add together to make a whole number? Well, I'm thinking it must be this one and this one, because the 4 and the 6 will make 10, won't it? So then that become a whole number. So it's going to be that one there. It's going to be 8.6 plus 0.4. 8.6 and 0.4, if I add those up, look, you're going to carry 1. It's going to give me 9.0, isn't it? So it's 9.0. Or maybe I should just show it as 9. Okay, because it's a whole number. So it's 9. And then the second part says choose 2 of the cards to make the answer to this calculation as large as possible. Include the answer to your calculation. Okay, so in this subtraction, the largest possible answer I'm going to get is if I take the largest number and put it here. So this one needs to be the largest. and then this one here needs to be the smallest. So if I take the largest number and then take away the smallest amount, it's going to remain as large as it can be. So which one up here is the largest one? So 8.6 is the largest one, so that's going to go in the first box, isn't it? Okay, so I'm going to put 8.6 in here. And if I want to take away the smallest, then the smallest one is this one here, isn't it? 0.27, that's smaller than 0.4. So if I then take away 0.27, I should get the smallest value I can get. Okay, what is 8.6 minus 0.27? Don't forget to line up your decimals. And I'm going to add an extra 0 in here so then my columns match. 0 take away 7 can't do, it's going to have to borrow 1. So that's going to become 5, that's going to become 10. 10 take away 7, that's 3. 5 take away 2, that is 3. And 8 take away 0, that is 8. So it's going to be 8.33. Question 9. Jenny buys 5 rulers and 2 pens. She works out how much she should pay. And then we've got a little signs up here saying rulers are 85p, pens are £3.50. So she works out that 5 times 85p is £4.25. 2 lots of £3.50 is £6.10. She's added those together and got a total of £10.35. Jenny's total is wrong. Yes, it is. What mistake did she make? Include the correct total in your answer. Well, I don't know about you, but I spotted it straight away. It's this line here, isn't it? The 3.5, £3.50 times 2. £3 and £3 are £6, 50p and 50p is £1, so that gives you £7 altogether. I don't know how she's ended up with £6.10. That's not correct. Okay, so I think it's that one there. So what it should be is 2 times 3.5 should be equal to £7. Okay, now is the top bit right? Is 5 lots of 85p £4.25? Well, timesing by 5, I kind of times by 10.5. So 85p or 0.85 times 10, that's £8.50, and half of £8.50, that is £4.25. So that does seem to be right. Okay, so I think that first bit is right. So 5 times 85p, that is £4.25. So then the total is, adding it together, so 5 and 0 is, 5 and 0 is 5, 2 and 0 is 2, 4 and 7 is 11, so it's £11.25. So I'm just going to finish this off and say that the mistake, she miscalculated. 2 times £3.50, and the real total should be £11.25. Okay. Question 10. Here are 3 calculations, A, B, and C. Put the calculations in order. Start with the calculation as the smallest answer. You must show your answer to each calculation. Okay, so I've got some big numbers to multiply here. Now when I've got 2 numbers like this multiplied together, I tend to multiply the digits at the front together. So 1 times 2 is 2, and then I count how many zeros I've got. I've got 1, 2, 3, 4, 5, 6. So I'm going to add that number of zeros on the end. So 1, 2, 3, 4, 5, 6. So I believe that's 2 million. Just checking, look, I've got the same number of zeros as I got before, and the 2 comes from 1 times 2. Okay. For B, 1 million divided by 2. Now a million is a 1 followed by 6 zeros. That's a million. So half a million is going to be 500,000, isn't it? Okay. Halving a million, you're going to get 500,000. And then C, 4 times 100,000. Again, going to multiply the digits together. 4 times 1 is 4. And then I'm going to count the number of zeros. 1, 2, 3, 4, 5. And add those on the end. 1, 2, 3, 4, 5. Okay, so I got the 4 from the 4 times 1, and I got all the zeros from the zeros. Okay, so which one is biggest? Well, 2 million is biggest. Next biggest is 500,000, and the teeny tiniest one is 400,000. So smallest to biggest, is going to be, okay, start with the calculation that's the smallest. You must show your answer. Okay, so the smallest answer is 400,000. And then I've got 500,000. And then I've got 2 million. In that order. Okay, from smallest to largest. Question 11. In a raffle, 200 tickets are sold. The tickets are either red or blue. The winning ticket is picked at random. Now, question A says, what is the probability of a winning ticket being green? Well, how many green tickets are there in there? None. So what's the probability of pulling out a green one? None. So it's 0. 0 out of 200, which is just 0. It's impossible. Can't pull a green ticket out when they're only red and blue. Let's move on. 79 children and 90 women buy one raffle ticket each. Men buy the rest of the tickets. Work out the probability that a man buys the winning ticket. Okay, so all the tickets are sold. 79 went for children and 90 went for men to women. So the number of tickets for men is going to be the 200 tickets minus the amount they sold to the other group. So the 79 for the children and the 90 for the women. Okay, so what's that then? 79 plus 90, that's 169, isn't it? 169. So what's 200 minus 169? That's going to be 31. Okay, if you can't do that in your head like me, just do it like that. You know, that will work. How would I do that? 0 take away 9, I can't, so I'm going to borrow 1 from the 0. I haven't got anything to borrow, so I'm going to have to borrow 1 from the 2. That becomes 1. That becomes 10, but then I'm going to borrow 1 and it's going to make 9. That's going to become 10. 10 take away 9 is 1. 9 take away 6 is 3. 1 take away 1 is 0. So it's 31, like I said. Okay, so you could do it that way. I just kind of worked it out, kind of jumped down the number line to work it out. So anyway, I know there are 31 men, so then the probability that a man wins is going to be the number of tickets that men bought divided by the total number of tickets sold, which was 200. So it's going to be 31 out of 200. Question 12. A college has a total of 105 teachers, 19 more female teachers than male teachers. What proportion of the teachers are female? Okay, now it doesn't say it here, but questions like this are easiest done with algebra. Okay, because you're comparing two values, but you don't know what those values are. It's really easy, or makes it a lot easier to use a bit of algebra. Okay, so we don't know how many women teachers are, but we know they've got 19 more than the male teachers, and we don't know how many the male teachers have got. So let's say the male teachers, let's call them Y, okay? And then female teachers, I was going to use X, but I thought Y was more appropriate for male teachers. And then female teachers is going to be 19 more. So 19 more than Y is Y plus 19. Okay, so then the total number of teachers is those added together, isn't it? Y plus 19, which is going to be 2Y plus 19. Now, we don't know what Y is yet, but we do know the total. We know that there are 105 teachers altogether. So if I do add the males and the females together, I should get that total of 105. Okay, so now I've got a linear equation in Y that I can solve. I want to try and get Y by itself. I'm taking Y, I'm timesing it by 2 and adding 19. So BIDMAS, if I was working that out, I would do the multiplication first, and then I would do the addition if I was working out what 2 lots of something plus 19 was. But when we're kind of unwinding equations like this, we kind of go through BIDMAS backwards. So we're going to deal with the addition first. The opposite of addition is subtraction, so I'm going to take away 19 from both sides. Okay, so that's going to cancel with that. It's going to leave me with 2y on the left, and then 105 take away 19. Well, 19 is almost 20, isn't it? So 105 take away 20 would be 85, plus 1 back is 86. So that's going to be 86. And then divide both sides by 2. they're going to cancel, leave me with y. Y is half of 86. Well, half of 80 is 40, half of 6 is 3. It's going to be 43. Okay, y is 43. Question 13. By rounding each number to the nearest 10, estimate the value of 262 divided by 19.8. Okay, so the nearest 10, so the tens is that middle number of that one. So if I'm going to round off after that 6, I'm just going to look at the next digit along after I round it off and see if it's 5 or more to raise the score, or 4 or less to let it rest. In this case it's 4 or less. So I'm rounding down in this case, so my digits 2 and 6 stay as being the digits 2 and 6. But 26 is not a good estimate of 262. So if I'm rounding off like this, I need to kind of pad it out with enough zeros to make my original number, my rounded number, the same magnitude as the original number. Okay, and then I'm going to divide by, what am I dividing by? The tens in this case is that one there. It's 19, isn't it? It's the 1 is in the tens column. So I'm going to round off after the 1. Now the next digit after the 1 is a 9. So in this case, 5 or more raise the score. So we're going to raise that 1 up. So the 1 becomes rounded up to a 2. And then I have to pad it out with enough zeros to make my rounded number the same size as the original one. So the original number was in the tens. So this is going to be 20. Okay, so I've got 260 divided by 20. So I'm going to just cancel that 0 into there and do 26 divided by 2. 26 divided by 2 is 13. Okay, so it's super easy once I've rounded it off to the nearest 10. It's 13. Question 14. ABEF and ACDF are rectangles. I've been given some information here. AF is 10, AB is 2, BC is 4. Now this information up here is not on the diagram, so I'm going to add that in first. So I'm told AF is 10, so I'm going to write 10 centimeters along this side. AB is this little bit in here, so that's 2 centimeters, and BC, this bit down here, is 4 centimeters. Okay. Right, that's I think that's all I need to know. Work out the perimeter of ABEF to perimeter ACDF. Now ABEF, and then back to A, I suppose, is that perimeter there, isn't it? So if I was to work out the perimeter of this shape, the perimeter is going to be 2 plus 10 plus 2 plus 10. That comes to 24. And then for the larger shape, I'm going to be going from A to C to D to F and back to A again. Okay, so the distance from A to C is that 2 plus the 4, isn't it? It's going to be 6. So the perimeter of the larger rectangle is going to be 6 plus 10 plus 6 plus 10. What's that come to? So 20, 26, 32. So that comes to 32. Okay, so then the perimeter of ABEF, that was the smaller one, to the perimeter of ACDF, that was the larger one, that is going to be in the ratio then of 24 to 32. Now it does say give your answer in its simplest form, and this one can simplify because I can see that 24 and 32 have got some common factors. What is that? I think 4 go into both of them. Oh, 8 go into both of them, don't they? I can divide them both by 8. So it's worth just spending a bit of time to see if you can find a bigger common factor before you go ahead and divide, because it would just make your life a little bit easier. You don't have to do so many jumps. So 8s into 24 go 3 times, and 8s into 32 go 4 times. So that's my ratio then, 3 to 4. Question 15. ADB and CO are straight lines. Angle ADC is 5 times angle ACD. Work out the size of angle ADC. Okay, angle ADC. What's ADC? ADC. So this angle here, that is 5 times bigger than angle CDB. CDB, this one here. Okay, Now again, it's one of those situations where we're comparing two things and we don't know what the thing is that we're comparing. So I'm going to use a bit of algebra again. I'm going to say, well, let's the smaller one be x, and then the larger one is going to be 5 times bigger. 5 times x is 5x. Okay. Now I do know that angles on a straight line sum to 180 degrees. So if I take those two angles, 5x plus x, then add them together, I should be getting a straight line which is 180 degrees. But 5x plus x collecting like terms is 6x, so that tells me that 6x is equal to 180, and then if I divide both sides by 6, 6 is into 180, that goes 30 times, doesn't it? So x equals 30. So then CDB, the smaller one, that is going to be 30. And then the larger one, ADC, is going to be 5 times bigger. It's going to be 5 times 30, which is 150 degrees. And that's the answer we're asked for, aren't we? We're asked for the angle of the larger one, ADC. So that one is 150 degrees. Question 16, circle the value of 5 cubed. 5 times 5 times 5, well, I recommend you just memorize your cube numbers, at least the first 5, probably more than that, first 10. If you had, you'd know straight away what the answer to this is. I already know it, but let's assume you don't. 5 times 5 times 5. I'm going to multiply those together first. It's going to give me 25, and if I times 25 by 5, 25, 25, 25, 25, 25, that is 125, isn't it? It's that one there. But really, just memorize your cubes. Really handy for your exam. Question 17, draw the graph of y equals 3x minus 1 for values of x from minus 1 to 3. Now, if this was the calculator paper, I'd just get you to use the table function on your calculator. Check out the other videos I've done for examples of how to do that. But this is the non-calculator paper, so we're not going to be able to do the super cheaty easy way on the calculator. We're going to have to work it out long ways. Okay, so I'm going to make a table of values. Now I'm told that the x values run from minus 1 to 3. So I'm just going to work out all of those values. Minus 1, 0, 1, 2, and 3. Okay, so remember the equation of my line is y is equal to 3x minus 1. So what I'm going to do is I'm going to take each one of those numbers in turn, and I'm going to substitute it in for the x here, and then work out what the corresponding value is of y. Now, sometimes it's easy to start at the positive end and work downwards. So I'm going to start with a 3, put that in first, and then kind of go through my list backwards. So when x is 3, then I've got y is equal to 3 lots of 3 minus 1. 3 times 3 is 9, take away 1 is 8. So 3 goes with 8. When y is 2, I'm going to get y equals 3 lots, sorry, when x is 2, I'm going to get y as 3 lots of 2 minus 1. 3 times 2 is 6, take away 1 is 5. And then when x is 1, 3 lots of 1 take away 1. 3 ones are 1, 3 take away 1 is 2. And then usually after a while you start spotting the pattern. Can you see the pattern yet? So 3 lots of 0, take away 1, that's minus 1. You're probably seeing that these are kind of going down in threes, aren't they? So minus 3, minus 3, minus 3. So you probably know what the next one is already. It's minus 4. Let's just double check. Y is equal to 3 lots of minus 1, minus 1. 3 lots of minus 1 is minus 3, take away 1 is minus 4. Okay, so now I've got my points I can plot, because each one of these then makes a coordinate then I can plot on my graph. Okay, so the first one is minus 1, minus 4. So I'm going to have a cross then at minus 1, minus 4. It's down here. Then I've got 0, minus 1. 0 minus 1 is here. 1, 2, 1, 2. 2, 5, 2, 5. And 3, 8. 3, 8. Okay, now this is a linear equation. It's in the form y equals mx plus c, so you should be expecting to get a straight line. Now, if you plot all your points and it doesn't form a straight line, you should know immediately you've made a mistake and go away and see if you can find it. You should be expecting a straight line. If it isn't a straight line, you've gone wrong. Okay, so do have a think about what graph it is that you're drawing. In this case, this is definitely the form y equals mx plus c. It's definitely a straight line. Don't get a straight line, you did it wrong. Fix it in the exam rather than crying when your results come back. Question 18. Mo played 30 games of chess. He won 18 of these games. What fraction of the games did he win? Give your answer in its simplest forms. Well, he won 18 games out of a possible 30 games. So the fraction he won then is the number he won over the total number, which is 30. Can you see any common factors there? I can see that 18 and 30 are both in the 6 times table. So I'm going to divide top and bottom by 6 then, just to simplify this down a bit. 18 divided by 6 is 3. 30 divided by 6 is 5. Now they're both prime, so I'm not going to find any more common factors there. So 3/5 is my most simple answer. Okay, question 18b. He played 20 more games. He then won 64% of all of his games. How many of the 20 games did he win? He played 20 more games. So if he played 20 more games, how many games has he played altogether now? So total games is going to be the 30 played at the beginning plus the 20 more games, giving him now a total of 50 games. Now he won 64% of all of his games. So what is 64% of 50? Okay, 64% of 50. Now I know 64% of 100 is 64 because it's out of 100, isn't it? So 64% of 50 got half as much. It's going to be half of that, isn't it? It's going to be 32. Okay, 64% of 50 is 32. So how many games of the 20 did he win? He'd already won 18 the first time around, and now he's up to a total of 32 wins. So his new wins is going to be the 32 wins minus the 18 wins he'd had earlier. So 32 minus 18, what's that, 14? So he's got 14 new wins then. So he won 14 of the 20 new matches. Okay, seems to be improving. Question 19. In a field, the number of sheep to the number of cows is in the ratio of 10 to 3. So Zach says there are 10 sheep in the field. Give a reason why Zach could be wrong. Well, if they're in the ratio of 10 to 3, there could well indeed be 10 sheep in the field and 3 cows in the field, but it could be some multiple of that ratio as well. I could take that ratio and double it and get 20 to 6, so like 20 sheep and 6 cows. Now that would still be in the ratio of 10 to 3 because these are equivalent ratios. Okay, so it's not necessarily going to be 10 sheep. I'm going to say it could be some multiple of 10, e.g. 20 or 30. Okay, so it could be 20, or it could be 30, or it could be some other multiple of 10. Okay, I think that's good enough. It's just a 1 marker, this. They're not expecting, an essay. Just a quick reason why you think that is. That's totally acceptable. 19b. In a different field, the number of goats to the number of pigs is in the ratio of 13 to 4. Priya says there are more than 3 times as many goats as pigs. Is she correct? Okay, are there 3 times as many goats as pigs? Now, if you take 4 and you multiply it by 3, 4 times 3 is 12. Okay, so if there were 12 goats to 4 pigs, that would be 3 times bigger. But actually, we've got 13 goats to 4, so that's more than 3 times bigger, then, isn't it? So that means that there are more than 3 times as many goats as pigs. So she is correct. So I write 4 times 3 is 12. So the ratio 12 to 13, I'm just going to say 13 is greater than 12. So it is more than 3 times. Okay, I just want to make sure I've got the mark there. Question 20. An ordinary fair dice is rolled, and the probability of event A is equal to 5 over 6. Which could be a correct statement about event A? Tick one box. This is kind of an interesting question. They've given you the probability this time, but haven't told you what the event actually is. So you're going to have to see if you can come up with the event that matches that probability. Okay, so the number of rolled is even. Well, there are 3 even numbers on a fair ordinary dice, isn't there? There's 2, 4, and 6. So the probability of that is going to be 3 over 6. It's not going to be 5 over 6. So it's not that one. The number rolled is greater than 1. Well, how many dice are greater than 1? So that was 2, 4, 6, wasn't it? Now this one is going to be 2, 3, 4, 5, and 6 meet that criteria. So there are 1, 2, 3, 4, 5 of them. So I do think that is 5 to 6. I think it is going to be that one. Let's just double check the others. The number rolled is less than 5. Well, the numbers that are less than 5 are 1, 2, 3, and 4. There are only 4 of those, so that's 4 out of 6. And then finally, the number rolled is prime. The prime numbers on the dice, 2, 3, and 5. Only 3 of those. That's 3 out of 6. So yeah, that's the only one that meets the criteria. The number rolled is greater than 1. Solve 8x plus 7 is equal to 2x plus 10. I'm just going to write it again down here so I've got a bit more space. X plus 7 is equal to 2x plus 10. So this is a linear equation, unknowns on both sides, considered the kind of one of the harder types. So first step is to try and reduce the complexity of your equation. Now you notice I've got x's on both sides. I've got 8x and 2x. Now what I tend to do is I take away the smaller one from both sides. So 2x is smallest out of 8x and 2x. So if you take it away from both sides, you can see that that 2x take away that one is going to cancel each other out. And 8x take away 2x, well that's 6x. Okay, so now I'm left with just 6x plus 7 is equal to 10. So this is a more kind of simple looking linear equation now. So next step is to do away with that plus 7. Again, I talked earlier about going through BIDMAS backwards when you are unwinding these equations. So I'm multiplying by 6 and I'm then adding 7 if it was a sum to work out. Now when you're solving these, we kind of go through backwards. So you're going to deal with the addition first and then the multiplication. So taking 7 away from both sides, that will cancel and leave me with just a 6x on the left is equal to 10 minus 7, that's 3. And then dividing both sides, the opposite of times and is dividing. So dividing both sides by 6, that's going to cancel. Leave me with x on the left. And 3 divided by 6, that's the same thing as a half, isn't it, or 0.5. It's a half. In a right angle triangle, the ratio of the smallest angle to the largest angle is in a ratio of 2 to 5. Okay, so work out the 3 angles of the triangle. Now notice we haven't got the medium angle in here. Okay, we haven't got the medium one. So what are the possibilities here? If it's a right angle triangle, it could be that the middle one is going to be somewhere between 2 and 5. So the ratio from small to medium to large. So small is 2 and medium is 5. Now for the smallest to be the smallest, then the medium one is going to have to be a number between 2 and 5. Now I think it could actually be 2, couldn't it? And that would still make the smallest 2. Or it could be 2 to 3 to 5, or it could be 2 to 4 to 5, and I suppose it could also be 2 to 5 to 5. Okay, but what I'm suspecting is that if that is the case, then probably it doesn't work for the fact that one of them has to be a right angle triangle. So only one of these combinations is going to work with a right angle triangle. Okay, so like if I add these parts of the ratio together, you know, if you're dividing by a ratio, you kind of add the bits of the ratio together and then divide into your total. Now we've got 180 degrees to share out between these 3 angles, haven't we? So it's like a dividing by a ratio question. So if it was 225, then that is 9 shares altogether. 235 is 10 shares altogether. 245 would be 11 shares altogether, and 255 would be 12 shares altogether. Now in order for one of them to be a right angle triangle, we're going to have these numbers dividing into 180 without leaving a remainder. In other words, it's only going to work if these numbers are factors of 180. So looking at this straight away, I can rule one of the options out. It cannot be 245 because that adds up to 11, and 11 does not divide into 180. So that one's definitely out. Now 10 divides into 180, 9 does, and 12 does. So we've kind of ruled one possibility out. I'm thinking it's probably that one in the middle, the 10, but let's just think it through. So if we were dividing 180 by 9, then each share would be worth 20 then, isn't it? 9 goes into 180 20 times. For the second one, if it was 10 shares, then 10 goes into 180 18 times. And then if there were 12 shares, 12 goes into 180 15 times. Okay. Now, in order for to get the right one of these combinations is going to have to deliver like a 90-degree angle somewhere. Okay. So if each share of the first one is worth 20, then I'm going to have a 40, 40, 100 angle. So that does not work. I haven't got a right angle there. Okay, with the second one, I've got 18 times 2, that's 36. 3 times 2, that's, sorry, 3 times 18. 3 20s would be 60. Take away 6, that's 54. And then 5 18s, ooh, 5 18s is 90. So that one does work. Let's just double check the last one. 2 times 15 is 30. 5 times 15, that's 75, and 75 then, isn't it? So that one does not work because none of them are a right angle. So it's going to have to be this one here. So what are the three angle sizes? It's going to be 36 to 54 to 90 then, isn't it? That's the three angles. So it's 36 degrees, 54 degrees, 90 degrees. Question 23, which one of the following is discrete data? Circle your answer. So you've got two types of data, haven't you? You've got discrete and continuous. So discrete data is one that comes in kind of distinct, usually whole numbers, not necessarily whole numbers, but you know, it comes in equal, like in jumps. Whereas continuous data could be anything between a given range. Now, length of an arm, you would normally measure that in something like centimeters. This, heights, lengths, these are all continuous. That's continuous. Height of a door is also measured in like centimeters or meters or something. That's also continuous. Number of pets or mass of sugar. Mass is measured in grams. Again, that one is continuous. So the only one that is discrete is the number of pets. You have like 1 pet or 2 pets, 3 pets, but hopefully you don't have like 2.579 of a pet, because that would be not very pleasant. Okay, just stick with whole number of pets. That's my advice. Here are two triangles, P and Q, and here is a statement. A transformation that maps P to Q is a reflection in the line x is equal to -1. Make one criticism of the statement. Well, the line x equals -1. What line is that then? That is, it's this line here. X is equal to -1 is the vertical line passing through the point x is -1. Now that is not the mirror line between these two. It's not a line of symmetry between P and Q, is it? Actually, where the mirror line is going to be this line, isn't it? Now this is the line, not x is equal to -1. It's actually the line y is equal to -1. Okay, so my criticism here is that he's written the wrong value of the equation down. So I'm going to write down equation of mirror line should be y is equal to -1. Question B says, here are two shapes C and D, and here is a statement. A transformation that maps C to D is a rotation through 90 degrees anti-clockwise. Okay, make one criticism of the statement. Well, I think that is a 90 degrees anti-clockwise rotation, but there's something missing from the description of this transformation. When you're describing a rotation, you need to mention one other piece of information. You need to always mention where the center of rotation is, and that is missing in this statement. So my criticism is that there is no center of rotation given. Okay, that's my criticism. I could go on and say where the center is. I'm thinking the center is going to be there at the origin. So I might write that down because I know what it is. So center of rotation is 0, 0. So I'm just going to write that down. Probably didn't need to. Probably just saying that there's no center of rotation is enough. But I'm a smart pants, so I thought I'd write it all down. A geometric progression starts 4, 16, and so on. Work out the next term. Now, is 2 terms enough to work out what's going on with this sequence? Well, we know quite a lot about it because we're told right at the start it's a geometric progression, and what that means is that there is a common ratio between one term and the next. In other words, you multiply each term by the same value to get the next term. Okay? Now we call the first term of a geometric progression A, and if it has a common ratio, this multiplier that we're going to use of R, then the second term is AR, and then the third term after that is going to be AR squared, and so on. Now, in order to find what R is, this common ratio, you can take any 2 adjacent terms. So I can take this 4 and the 6 here, and I can divide one by the other. So you see, if I take AR and I divide it by A, I should be left with R. So AR divided by A is going to give me R, isn't it? So if I take my 16 and I divide it by 4, I'm going to get 4. So that's what R is. So R is 4. So if I know R is 4, then I know the next one in this sequence is going to be 16 times 4. So double 16, 32, double it again is 64. Okay, so that's my third term. So third term equals 16 times 4, which is 64. Okay. Part B says a Fibonacci type sequence starts 3 and then -8. The sequence is continued by adding the previous 2 terms. Okay, so work out the next 2 terms. So the third term, T3, is going to be T1 plus T2, isn't it? The first term plus the second term. So that's going to be 3 plus -8, which comes to -5. And T4, the fourth term, is going to be T2 plus T3. So we're given T2, it was -8. And T3 we've just worked out to be -5. So -8 plus -5, what's that then? That's -13. Okay, so there's my third and fourth term, -5 and -13. Given that A times 60 equals B, work out the value of 4B divided by A. Okay, if I've got 4B divided by A, I know that my B here is the same as this B here, so I can replace it with A times 6 then, can't I? So I can say that that is equal to 4 lots of A times 60 over A. So let's remove the brackets first. 4 times A times 60, that's going to give me 4 times 60, 60, 120, 240. So 240A divided by A, and then my A's are going to just cancel each other out, aren't they? It's going to leave me with 240 as my answer. Right, 27 times 3 squared, all raised to the power 7 as a single power of 3. Okay, let's take this first part here, 27. Now 27 is a power of 3 already, isn't it? So you've got 3 times 3 is 9 times 3 is 27. So 27 is 3 cubed, and that's that bit there. If I take this second bit, 3 squared raised to the power of 7, I've got an index of an index, haven't I? So in this case, I just need to multiply these two values together, because I've got 3 squared multiplied by itself 7 times. So it's going to give me 3 to the power of 2 times 7 is going to give me 3 to the power of 14. Okay, so that's from the second one there. And now I've got two numbers with the same base, 3 and 3, and I'm multiplying them together. So that is the same thing as 3 to the power of 3 plus 14, which is 3 to the power of 17. Okay, so that's my answer, 3 to the 17. Here are two solids. We've got a cylinder, and we've been given its radius of 4 and its height of 10. And we've got a hemisphere, and we've been given its radius of 6, and we've been given the formula for the volume of a hemisphere. We're told it's 2/3 pi r cubed. Okay, which solid has the greater volume? You must show your work in. Okay, so I just need to work out the volumes of each of these and then compare them, don't I? Okay, so let's have a look at the cylinder first. Now, they don't give me the formula for a cylinder, but a cylinder is just a circular prism, and a prism has a volume of its cross-sectional area, in this case it is a circle, times the distance between them. So it'll be pi r squared for the area of the circle times h, the distance between the top and the bottom circle. Okay, so subbing in what we know, I'm going to get pi times 4 squared times 10, aren't I, for the volume of this cylinder. 4 squared is 16, times 10 is 160. I'm just going to leave it as 160 pi. I just need to compare it with the hemisphere calculation, and that's also got a pi in it. So I can just compare the coefficients of pi then, can't I? There's no point in multiplying it by a really horrible 3.14 or whatever. So let's just leave it as 160 pi. So switching over to the volume of the hemisphere, volume of this is 2/3 pi r cubed, and we know that r is 6, so it's 2/3 of pi times 6 cubed. Do you know what 6 cubed is? You should. You should know all your cubes. Well, first, certainly the first 10 comes in really handy. So 6 cubed is 216. But another way of thinking about it is 6 times 6 times 6. One of those 6's you're going to divide by 3. So it's actually going to be 6 times 6 times 2. So 6 times 6 is 36. 6 times 2 is 72, times another 2 is 144. I make that 144 pi. Alternatively, like I say, you can multiply out 6 cubed, get 216, divide by 3, and then times by 2 to get 144. Okay, so either way, I've got 160 pi and 144 pi. So clearly 160 pi is bigger than 144 pi. So which has got the greatest volume? The cylinder has the greater volume. Sarge makes rose pink paint and cherry pink paint. He mixes red paint with white paint as shown. To make rose pink, he needs 1 part red to 2 parts white. And for cherry pink, he needs 4 parts red to 3 parts white. He makes 60 litres of rose pink paint. To this rose pink paint, he adds 80 litres of red paint and 28 litres of white paint. Has he now made cherry pink paint? You must show your working. Okay. Ooh. So anyway, let's try and work out where we're starting from. He makes 60 litres of rose pink paint. So let's start with that then. So he's starting with 60 litres of rose pink paint here. Now we know that the ratio of rose pink is 1 to 2, 1 part red to 2 parts white. So how many red litres and how many white litres are in that 60 litres of rose pink? So if I've got 60 litres of rose pink, then what is 60 divided by the ratio of 1 to 2? So 1 plus 2 equals 3, doesn't it? I've got 3 parts altogether. 1 plus 2 equals 3. So dividing 60 by 3 gives me 20. So if I take the ratio of 1 to 2 and I scale it up by a factor of 20, I should get how many pots of red and how many pots of white paint have been put in. So 1 times 20 is 20, and 2 times 20 is 40. So I've got 20 litres of red paint, then, haven't I? And 40 litres of white paint to start with. Okay, so from this starting point, he now adds 80 litres of red paint and 28 litres of white paint. Okay, so on my 20 litres and 40 litres, I'm going to add a further 80 litres and 28 litres, adding that on. What's that going to be? 20 plus 80 is 100 litres of red, and 40 plus 28 is 68 litres of white then, haven't I? Okay. Is this the same thing as cherry pink paint? Well, it will be if we work out that the red to white ratio is now in the ratio of 4 to 3. So we've got 100 to 68. Now, have they got any common factors? Well, 68 is in the 4 times table, and so is 100. So let's divide it by 4 to start with and see what we've got. So 100 divided by 4 is 25. 68 divided by 4 is 10 in 40, and what's that? 7 in 28. So give me 17 altogether. 25 to 17. That doesn't look right. I don't think I'm going to be able to cancel that down to 4 to 3, am I? It's not going to be possible. Now that 17 at the end there tells me it doesn't have any more factors that I can cancel it down by, because 17 is prime, isn't it? So 25 to 17 is the simplest ratio I'm going to get out of these two amounts. So it's pretty close to 4 to 3, 25 to 17, but it's not exactly 4 to 3, and therefore I don't exactly have cherry pink. I have a cherry pinkish. Okay, so what can I write down? How has he now made cherry pink paint? No, this is not cherry pink. Okay, so the ratio is 25 to 17, not 4 to 3. Just to really spell that out. I think it's obvious as it is, but hey. Work out 2 times 10 to the 14 divided by 8 times 10 to the 9. Okay, give your answer in standard form. Now when you're dividing two numbers in standard form like this, I'd recommend that you divide the mantissa parts together. So you divide those number parts into each other, and you divide the powers of 10 into each other separately. So that is going to give me, well, 10 to the 14 divided by 10 to 9. Let's do the easy bit first. 14 subtract 9 is 5, isn't it? So it's going to give me 10 to the power of 5 as the power of 10. And then I've got 2 divided by 8. That's the same thing as 1 over 4, which is the same thing as 0.25, isn't it? So that is a quarter, or 0.25 times 10 to the 5. Now I'm told I need to give my answer in standard form. Is this in standard form? Nope, because this number part, the mantissa part, is not a number between 1 and 10. It's too small. So I'm going to have to make it a bit bigger, and I can do that by kind of taking a power of 10 out of my 10 to the 5. So if I kind of remove a 10 from it, so 10 to the 5 is the same thing as 10 times 10 to the 4, and then if I combine that with my 0.25, that's going to give me 2.5 times 10 to the 4 then, isn't it? And that is in standard form, and my mantissa is 2.5, which is in the proper range, and it's expressed as a power of 10. Okay, 2.5 times 10 to the 4. Right, part B says 6200.07 is 6.2 times 10 to the C plus 7 times 10 to the D. Work out the values of C and D. Okay, so that 6.2 these two digits here are going to be these two digits over here, aren't they? And this digit here is going to be this digit here in my answer. So how can I shift the 6.2 onto 6,200? I could do that if I multiplied it through by a power of 3. 10 to the 3 times it through by 1,000. 6.2 times 1,000 is 6,200. So that's going to be 6.2 times 10 to the 3 plus, what am I going to have to do with that 7 to shift the decimal point? How many jumps is it? 1, 2 jumps. So that's going to be times 10 to the minus 2 then, isn't it? 0.07 is 7 times 10 to the minus 2. I think that's right. Okay, so comparing our numbers here and here, so C then must be 3 and D must be minus 2. Okay, so that's my answer. C is 3, D is minus 2. If we're given a formula for V and H, we're told that V is equal to some constant divided by H. Which two statements are correct? Is V directly proportional to H? Is it inversely proportional to H? Is it directly proportional to 1 over H? Is it inversely proportional to 1 over H? Notice that these two words are in bold. When AQA put things in bold, it normally because students tend to flick over that part of the word and they don't spot it and they don't do it. So if you ever see anything in bold, but take extra note because it's important. Okay, it's what things that people normally overlook. So which two statements are correct? Now, if I was to write this down in proportion with a proportionality sign, I would say V is proportional to 1 over H. V, little fishy, 1 over H. So V is inversely proportional to H. So V is inversely proportional to H. So it's that one there. Or I could say that V is directly proportional to 1 over H. That is also true. You can find more exam question compilations over here. For more past paper walkthroughs, click down here. If you want to visit my Amazon shop with my recommendations for calculators, revision guides and other maths related stuff, click down here. Good luck in your revision and in your exams, and see you again next time.